In this video, we're going to learn about how to solve linear equations as well as other equations that simplify down to linear equations. So a linear equation is when you can write it mx plus b equal to 0. Basically that means is you have a variable to the first power and then numbers and nothing else. So you don't have any x squareds or x cubes or any other things like that. So let's go ahead and start solving them here. I'll kind of work my way from easier to harder in these examples. On the first one, we have 5x minus 3 equal to 12. So our rules of algebra that we've seen in the past are that if you have an equation, you're allowed to do something to one side of the equation as long as you do the same thing to the other side of the equation. And in case you never were taught why that is, you can think of an equation, let's see how bad my drawing is here, as kind of a balance scale. And the idea is, you currently have things balanced. Well, if you're going to go ahead and do something to one side, add something on there, then it's going to go out of balance unless you do the same thing to the other side to keep it in balance. So again, equations, whenever you do something to one side, whatever it may be, you want to do the exact same thing to the other side to keep everything balanced. So for this first one here, I'm going to choose to add 3 to the left to get rid of this part, but I also then need to add 3 to the right side. I would be left with 5x equals, and then 12 plus 3 is 15. Then I will go ahead and choose to divide by 5 here, and that will leave me with x equal to 3. So that was, again, about as simple as you can get for linear equations here. We only had to do 2 steps to get to the answer, but we just use our normal rules and we eventually get to the value of x. On this next one, you can see part B here, it's a lot of parentheses and brackets and everything here. So what we're going to do is, before we try to do what we did in the previous step, we're going to try to simplify each side and see what we have. The right side's easier to work with, so I'll start there. I would go ahead and distribute the 2 in. 2 times 5 is 10, and 2 times minus 3x is minus 6x. Now on the left side, we have that 5 in front, and you certainly could start by distributing that 5 in, but I found a lot of students make mistakes if they try to do that. It's best to work on the inside part, simplify that, and then move on to the outside. Also, the mistake I've seen here is students distributing a 2 inside the parentheses, but really the thing that's next to the parentheses is the negative sign. That is what we're going to distribute there. So the negative times 2x is negative 2x. Negative times negative 4 is plus 4. Then we still have this 2 in front and the bracket and the 5. Then we can go ahead and combine like terms on the inside there. Negative 2x is nothing like term to that, but 4 plus 2 is 6. Then we can distribute the 5 in, and that would give me a negative 10x plus 30 equals 10 minus 6x. At this point, we want to get all the x's on one side, all the numbers on the other. It doesn't matter which side you choose for them. The kind of default is to have all of our x's onto the left and then all the numbers to the right. Again, you didn't have to do it that way. Then I would have a negative 4x equals negative 20. And the last step, we divide by negative 4, and we get the answer x equals 5. So again, more work there, more steps involved, but it was the same concept, and we got our answer x equals at the end. Now, part C, you may complain at first because I said these are linear equations and they don't have x squared in them, and yet we do have an x squared right here. And in fact, when we multiply the left side, we're also going to have an x squared. And so technically, this is not a linear equation the way it's written, but it turns out the x squareds are all going to cancel out, which means it is in fact a linear equation. So let's do that. The left-hand side, we're going to multiply, and we can multiply by foiling. So f for the first is x squared. Outer is minus 5x plus 3x minus 15. And then we go ahead and subtract the x squared from both sides. And we see that's going to completely cancel things out. Then I'll go ahead and do it in this step. I'm also going to get rid of the x on the right side. So I'll subtract x there and move the number from the left to the right. So on the left hand side I have a negative 5x plus 3x minus x. So let's see, negative 5 plus 3 is negative 2, and a negative 1 makes it a negative 3x. On the right side, 4 plus 15 is 19. Then we go ahead and divide by our negative 3 here, and we get the answer negative 19 thirds. And the one thing I do want to kind of point out is a lot of times students will get used to answers being nice whole numbers like there were in A and B here. And then if they get a fraction like this, they'll think that they're wrong. I mean, I usually try to make examples where they work out to nice whole numbers because I like it that way myself. But definitely you shouldn't be scared of fractions. And I understand if you are right now, just kind of practice with them so you get more comfortable with them. That's very important. On part D here, this time we're actually in fact going to have x cubed in the problem until it cancels out. So I'll distribute on the right side there. X times that is 2x cubed. X times 1 is x. I can go ahead and subtract the 2x cubed here. And then I need to decide which side to have the x's and numbers on. For one time, I'm actually going to move the x to the right because there was no number on the right side. So it gives me one less thing to worry about here. 5 equals 4x. Then we divide by our 4, and we get x is 5/4. Now for our final two examples, they're both fraction equations, which again, fraction equations are not linear equations by definition here. These are actually called rational equations. Rational in math means fraction. And so we're going to have to play around with them. The best way to handle these problems is to multiply everything by the LCD. And in this case here, the LCD is going to be a 6x. Then when we distribute that 6x in, let's see what happens here. Well, the right side, 19 over 6x times 6x, the 6x cancels. We're left with 19. And then on the middle term here, we got 6x over 3x is 2 times the original 2 that was already there. And then in the first term, we have 6x over 2x is 3 times the original 3x minus 1 that was there. So then we go ahead and distribute that 3 in, multiply the 2 times 2. I'll go ahead and move the numbers to the right side. And let's see, 19 plus 3 is 22, minus 4 is 18. So then we divide by 9 here, and we get x equal to 2. Now I do want to point out something that's pretty important here, is that I did say that this was not a linear equation, even though after simplifying we did get a linear equation. And one of the things that's important is whenever you have a fraction, you cannot divide by 0. And it's possible that the number you get down here, that if you were to go back to the original equation and plug it in, that would make you divide by 0. And if that's the case, that can't possibly be an answer because you can never divide by 0, in which case you would cross out that answer. Now in this case, if you plug in 2 up there, you're not going to have any trouble. There's no denominators of 0 then, so that means 2 is a valid answer. But whenever you have these fraction equations, as well as some other types of equations which we'll see in the future, you really want to check your answer to make sure it didn't give you a 0 denominator. Okay, now on the second one over here, the LCD is x minus 2. And I'll do it a little bit quicker this time. On the right side, the x minus 2's cancel. We're left with 6. Then we have the 5 times the x minus 2. And then the x minus 2's cancel, giving you 3x. I'll distribute the 5 in here. 3x plus 5x is 8x. I'll move the 10 over there. And then I will divide by 8. And I get x equal to 2. And then wait a second. If I try plugging in 2 up here in the original problem, that would give me 0 in the denominator, which means this answer is not a valid answer. And since that was the only possibility, that means that this is no solution. In case you are wondering, there's a name for when you get an answer that doesn't work. This is called an extraneous solution. And it is definitely something you will see now and then throughout the class.